Hi, math lovers. Today on notes number 4, we're going to talk more about radicals and exponents. This is lesson P2 from your textbook. I have some problems here written down. If you'd like to pause your video and go ahead and write your problems down before we get started, that would be a great idea. I'm going to just go truck right away through them. Usually I pick problems from the textbook, but today I didn't. So again, if you want to pause, go right ahead. I'm going to keep going. All right, the first one I have here. I've got 2 over the cube root of 5. Now, I'm going to go ahead and I'm going to rationalize that. I know I cannot leave that cube root in the denominator. So let's see. I'm going to take that original, 2 over the cube root of 5, and I'm going to have to rationalize that. I'm going to have to multiply it by the root here. But wait a minute. If I multiply the cube root of 5 times the cube root of 5, that's not going to give me 5. That index of 3 means I need 3. I need a set of 3. I need triplets, right? So instead of multiplying by the cube root of 5, why don't I multiply by the cube root of 5 times the cube root of 5? Ooh, much more exciting. Or if you want, you could just say the cube root of 25. That's the same exact thing. Go ahead and multiply your numerator. So it's 2 times the cube root of 25 over my denominator. So I've got the cube root of 5 times the cube root of 5 times the cube root of 5, which is, of course, just plain old 5. Okay, so that's good. I've got the cube root of 27 here. Now, I know right away you're saying 3. Okay, but let's stop and think. We know we wrote down the other, well, remember notes number 1 where you wrote down all your cubes? That comes back to help you, right? You're looking at the cube root of 27. Bam, right there, 3. Okay, you can see it. Problem solving, problem sense, number sense is really important in our class, so you know it's 3. But 32, not so quick, okay? Not so quick at all. I'm thinking to myself, 32. I know 32 is 3 to the 5th. 1, 2, 3, 4, 5. Okay, so I've got 3, 5. This is what's going through my head. I need a set of 4. This set of 4 comes out, right? It comes out, and I've got a 4th root, and this 3 is left underneath, so it stays underneath that radical sign. So my answer is 3 times the 4th root of 3. Okay? We're going to do the same thing with 75. You know, maybe you're thinking to yourself, 75, I know that is going to be 25, or maybe you want to write 5 times 3, and then x times x times x. You know, totally fine if you want to go ahead and do that at the beginning. Here's a pair of 5s, so the 5 comes out. Here's a pair of x's, and x comes out, right? And then underneath, I still have a 3, and I have an x, so that's times 3x, okay? Notice that we have an odd power here because we have an odd power on our variable. We do not need to put any absolute value signs in. But look at my next one. This is going to be different. I've got the 4th root of 5x to the 4th. And right away, I know you're thinking 5x, right? 5x. But here's what I want you to think about. What if x is negative? All right, so say x is -2, right? I'm going to have -2 to the 4th power. And now that x is going to become positive. If I pull it out here, x is negative. So I need to tell my reader, hey, I have a positive, so it's really the absolute value of 5x, which would be 5 times the absolute value of x, okay? So if you have absolute value signs and around a variable, okay, and you need absolute value signs around a variable when the index is even, okay? So when your index is when your index is even, you're good. Here we would be okay, right? Our index is even. If it were negative, this would still be a negative, right? Because you got 3 of them in there. When the index is even, you also have to be careful when the numbers. All right, let's try down here where we've got to change these problems to an exponent. All right, yesterday we did power over root. I'm going to go ahead and I'm going to put the 1 in the index there of 2 in there. So this would be 3 to the 1/2 power. All right. So anytime you see something to the 1/2 power, I say to you, hey, what's 16 to the 1/2 power? You're thinking in your mind, you're saying, hey, what's the square root of 16? And you'll say that's 4. Okay. Over here, I've got 5 squared, and I'm taking the cube root of it. So power over root. So 5 to the 2/3. Okay. Got a couple more for us up top here. Let me slide this down so you guys can see them. Up here, I've got two fractional exponents in my fraction. There's a fraction in my fraction. Sounds like a Dr. Seuss book, right? Oh, my reaction. Notice that the bases are the same, so I can go ahead and I can subtract my exponents. You know, if you're not sure, you're a little flustered, what would I do if it were x squared over x to the fifth? Wouldn't I just go ahead and subtract my exponents? So let's do the same thing. So it's going to be 9 and then 2/3 minus 1/6. You guys are whizzes with your math, obviously. And you can go ahead and subtract 2/3 minus 1/6. That would be 4/6 minus 1/6, which would be 3/6, which of course is 1/2. Hey, we just talked about that down here. And I know the square root of 9 is 3. Suppose you did not know that. Suppose you flaked for a second. You know 9 is 3 squared, right? So let's think about 9 is 3 squared. So now you're multiplying power to a power. 2 times 1/2 is 1. So aren't I just back here at 3? Right? And just like I had down here, 16, what if I flaked? All right, so that's 4 squared to the 1/2. I just forgot for a second. Hey, that 1/2 is the square root. Power to a power and multiply. There I am again at 4. Isn't that beautiful? That is just awesome. All right, 2 more. I'm going to go ahead and I'm going to add these cube roots together, but here's my problem. They're not the same radicals, all right? So I need to go ahead. I cannot change this cube root of 6, or I can't break it down any further. But the cube root of 48, I can, all right? So cube root of 48, you know, is 8. 48 is 8 times 6, and in your mind, you're thinking the cube root of 8, well, that's 2, and then times the cube root of 6, all right? I love putting these questions on quizzes because kids will forget that there's a coefficient here of 1, all right? And separate those of you that are really thinking, and I add those terms together. So 1 times the cube root of 6 plus 2 times the cube root of 6 is 3 times the cube root of 6, okay? And this last one that I have over here, the 27 to the 2/3, I want to reduce that. Now, I'm thinking back. I got my cubes in my mind, and I know my cube of my 27 is 3 to the third, okay? See how I'm bringing that back again? So that's 3 to the third to the 2/3. Okay, now you're thinking to yourself, wait, look at those 3's. Remember this power of this exponent, this 3 is really over 3 over 1. And if you go ahead and you multiply these fractions together, you have 6 over 3, which is, of course, 2. Or you could just go ahead and divide those 3's out, and you've got 3 to the second, which is, of course, 9. Okay? If you didn't remember that, you could go ahead and you could say 27 and do your power over root, and you could think about this as, oh gosh, the cube root of 27 times 27, right? And then break this down to your factor tree. And you know the cube, you know, you could go through those steps, but you're just going to come back to 9. Okay. All right. Good luck in your homework assignment. You're on problem set number 4 today. Use your book as a reference. Don't forget to check your answers with CalcChat as you go. Have fun.